For each of the quadratic functions graphed below, find the coordinates of the vertex, determine if the vertex is a maximum or minimum, and write the equation for the axis of symmetry. So I'm going to go a little out of order, starting with the axis of symmetry. When I look at this first example, I should be able to see that vertical line, that axis of symmetry that cuts that parabola into two equal halves. And that axis of symmetry is the vertical line, x equals -3. Now the vertex is the one point of your parabola that falls on that axis of symmetry. I can see the x value of that vertex is -3 and the y value is 1. So notice the x value of your axis of symmetry is the same as the x value of your vertex. Now when I look at this parabola, it is opening down, which I call a sad parabola. And sad parabolas, their vertex is the highest or maximum value on the curve. So that's going to be a maximum for our vertex. Looking at the next example, I can eyeball and see this axis of symmetry, this vertical line, x equals 1. Remember, my vertex is the one point of my parabola that falls on that vertex, 1, -4. And notice this x value is the same x value as my vertex. Now, when I look at this parabola, it is opening up, so it looks happy. So that means that that vertex is going to be the lowest or the minimum value of that happy parabola. And last but not least here's my axis of symmetry, cutting that parabola into two symmetrical halves, x equals 0. My vertex is the one point of my parabola that falls on that axis of symmetry, 0, -2. And notice this x value is the same x value here. And once again, this parabola is a happy parabola because it opens up. So the lowest it goes is its vertex or its minimum.